Yeah, let's start. Yes. Yeah. It doesn't really matter. So if you're here, then you can just yeah. Okay, so for this tutorial, I'll be talking about milestone 1, and I'll be walking through one of the functions that you'll need to implement for milestone 1, just to get you started. So the code that you're given consists of 4 parts. We have 2 libraries, 2 APIs. One is the streets database library and the street map library. And you have your own main executable, and you have the Tetra executable that's given. The streets database library is given to you, so you cannot modify it, but you can use it, and it will provide with everything you'll need for this milestone. The 2 executables will talk to the street map library that you will be implementing. And in this milestone, you'll be implementing the queries, which includes all of the loads, close queries, everything that you'll need to pass the tester. So to start, you'll need to read the handout, which I believe most of you have done. You'll need at least 1 global variable to pass the performance test. And anyone knows why? Why do we believe that you will need at least 1 global variable? Anyone? We have chocolate bars. Why do we need at least 1 global variable to pass the performance test? Well, at least we think you will need at least 1 global variable to pass the performance tests. Why is that? Yep. No. Yep. Of the map. Yeah. So by saving information that you need from the map will help you get the information quicker. You can get a chocolate bar if you want. And to save the data that you want, we'll be using you can choose one. We'll be using the containers from the STL. And I will be going through which container should we choose in which case. So the information you will get about the map will be intersections, each having a unique intersection ID connected by street segments. So 2 intersections are connected by 1 street segment. And the street segments all have a unique C-segment ID. So you can have 1 street, but 1 street can contain many street segments. There will be 1 street segment connecting 2 intersections. So this is what you're given in the m1.cpp file. You have a load map and a close map. The load map will be called once when the program starts. And the close map will be called once when your program ends. So this is where you will clean up everything you will need to clean up. The first steps for M1, first is to compile and run the tester executable ECE297 exercise 1. And without modifying anything, you will likely see this. Undefined reference to a lot of functions. This means that you have not implemented any functions by this time. So in order to get you be able to compile and run the tester, open up m1.h and you will see all of the function headers of the functions you will need to implement in this milestone, each of which are commented with the function description and the speed requirement. In this tutorial, I will be going over the find three segments of intersection function with you. Next step, create empty functions for all of the function headers in m1.h. And make sure you return something if the function requires to return something. So in this case, you will not be implementing anything except for empty functions. And make sure you will get no more build errors from the tester. And after the tester runs, you will get this. So this is a summary of all of the tests that's being run for milestone 1. And your goal for milestone 1 is to pass all of these tests. Now let's look at this single function that we'll be going through. This function, from the description, it asks us to return a vector of all of the street segments connected to an intersection marked by the intersection index, intersection ID. And our only input is the intersection ID number, which means that you will need to get the information for the intersection from the API, the street database API.h. If you go to this header file and open it, this is a snippet of the header file. Street segments are stored in a struct, street segment info, and here are just all of the fields for one street segment. Way OSM ID. OSM IDs are just unique IDs defined for all of the entities in this library. So this ID will be universally unique, meaning that it will be unique in all of the intersections, street segments, streets, and all of the cities. So this will be an enormous integer value. Intersection index from and to, marking the two intersection IDs connected to the street segment. One way means that if it's two, then it's one way. You can only go from to to. Otherwise, it's two-way. Number of curve points, the number of curve points of the street segments, speed limit, and the street ID where the street segment belongs to, which I think should be all straightforward. So the functions you will likely need are these three functions. These are all still in Street Database API. The first one, get num intersection street segment given the intersection index. We'll get to the number of street segments connected to intersection. The intersection street segment will get the specific street segment index, the segments connected to the intersection, and the get street segment info will return the actual street segment info of this specific street segment index. So the naming convention of all of the functions in Street Database API will be, it will first start with something like a get. A get means that you are getting something from it. And this is usually a O1 complexity operation. So you're getting something from the library. The first entity will be the entity that you are looking at, which is usually given in the first argument. So in this case, you're looking at an intersection. And the second entity will be the attribute you are looking for. And in this case, you're looking at the number of street segments for this intersection. All of the functions will follow this naming convention. So what will actually happen? Let's look at this intersection between St. George and Galbraith. So we have this intersection ID 232. It is connected to 3 street segments. All have a street segment ID like this. So the first step is to call get non-intersection street segment of the intersection ID. It will return 3, meaning that we have 3 street segments connected to the intersection. Then we loop from 0 to 3 minus 1 to get all of the street segment index 311, 321, 352. And we can then use the get street segment info of the street segment index to get the actual street segment info with data about the street segment. And one thing to watch out for is that the intersection index, street segment index, or any index that you will be seeing are mostly typed as to integers. So they are just integers, but with a different name. So if you accidentally use a street segment index to access an intersection, your compiler will not error out. So to prevent mistakes like this, we recommend making descriptive variable names, or just decide a naming convention in between your group. Something like _I for intersection index, _S for street segment index should be enough. Just decide a universal naming convention in between your group to minimize mistakes like this. And now you can split into your teams and in a text editor, or if you have your project M1 ready, you can VNC into the UG machine and try to implement an initial version of this function using the 3 functions that I just introduced. And we'll be back in a few minutes. Just remember, we are trying to return a vector of street segment index of street segments connected to the intersection.
Just order to like balance paper because it's gonna be number 12. So we can but if we weren't getting much problem, it's going to log in.
Yeah, you need to wait for volunteer to send out the email. I'm not sure. We don't need to see. I saw a post on the other day. Wait for him. Should get one. Should. You know your TA. Ask TA. Then you should go sort it out. By the way, if you have not checked out your repo, it can be a good opportunity to do it now. Anyone needs more time? I'll take that as a no. And let's continue then. So this is the most naive implementation for this function. So you're getting the number of intersection street segments from the intersection and looping from 0 to the number -1. And in your loop, you do the street segment index using get intersection street segment and pushing them back into the vector to be returned. And if everything goes right, after you run the tester on the intersection tests only, so this command will run the tester for the test containing intersection only. And you'll see that you're passing the functionality test in the performance. Meaning that logically this implementation works, but it's not fast enough. Then how do we solve the performance issue? Let's look at the performance requirements for milestone 1. We have 3 different levels of speed requirements. The high speed requirement means that we will need this function to be really fast. And we will be expecting you to create data structures that allow you to rapidly return the value that we need. A moderate means that this function is speed tested, but it's not required to be really fast. So a more straightforward implementation like what we just did should pass the test. None means the function is not speed tested. And the function we're looking at right now has a high speed requirement. So let's look at the function again. What is the complexity of this right now? Yeah. O(n)? Yes. And what is n? Think about it again. What are we doing right now? Like, getting the number of intersection street segments will be O1 time. Assume this is O1. You can answer if you have. Yeah, what is n? Number of yes, it will be the number of street segments connected to the intersection. Yeah, you both can get a chocolate bar if you want. So it will be O(n) or OK, where K is the number of street segments connected to that intersection. How can we speed up this function then? Yeah. Sorry, what was that? Yes, but because this we assume it's all one time, so it will not really impact the complexity by that much. So the massive hint is given in m1.cpp in this comment. Load your map related data structures here. So considering the function we're implementing right now, what data structure can we use for this function specifically? So the input of the function will be a single integer, intersection ID, which ranges from 0 to the number of intersections minus 1. The output will contain a collection of street segment IDs in the form of vector of integers. If we want to store them, we will want something that can take in the same input and give the same output. Let's take a look at the STL data structures that we have. A vector will take in an integer as input, and the integer will need to be ranging from 0 to a certain number, where the certain number is the size of the vector. The output can be templated, meaning that the output can be anything. And here is an example of how to get one element from the vector. The list will take in an input as an iterator, and it can store anything because the output is templated. And the example of how list will work. A map will have a templated key and templated value, and similar to an order map. Then the questions to ask: which data structures can be accessed with an integer intersection ID? All of them. And the list is really inefficiently, but we can access it by integers. These data structures can all contain anything because they're templated. And the complexity of accessing elements in the data structure will vary. Where vector will take O1 time, list will take ON. Math is O log n because it's a binary search tree. Unordered map is O1 because it's a hash. And we would want something less complex than what we are having now, which is definitely not list and not map. Then we are left with vector and unordered map. Both of them can access one element within O1 time. For vector, an access will be a direct memory access, which is a direct load instruction to the memory. And the load instruction will be covered in ECE243. But for unordered map, because it's a hash table, you'll need to first call a hash function to get the actual index and then do the direct memory access, which is slightly slower than vectors because the hash function also takes time. And in this case, we will then choose vectors because your input will be a number from 0 to size -1. And nothing can beat a vector in that case. When you use the unordered map, when the input, if it's integer, and we're looking at a really big number that's not continuous between 0 and the size of the vector, it will be really inefficient to use a vector. And if the index is as large as, say, the OSM ID that we have in our library, if we really create a vector for that, it will exceed our memory limit on our machines. So it's really inefficient. Or if we are not indexing with, say, an integer, we're indexing with a string, then we will need to use the on-order map option. But in this case, we're using the vectors. So the global variable will be a vector of street segment index. And in this case, we do one query into the vector and we'll get the actual return value that we want. And what will this contain? Will be a vector of integer. The vector will contain vectors of integers, like this. And each index will contain all of the street segments connected to the intersection. If we do intersection street segments 1, it will get intersection 1's street segment IDs in the vector of integer. Does this make sense? Anything unclear at this point? If nothing is unclear, let's break out into teams again and let's try populating this global variable inside the load map. And remember, the first line of load map will be loading the actual map from the streets database binary API. And let's get back in a few minutes. Okay, let's continue. So to load in this intersection street segments, global variable, we will first resize the outer vector to be the intersections. Then do a for loop going from 0 to non-intersection -1. And we have an inner field and gets all of the three segment IDs to the inner vector. Does this make sense? Anything unclear till this point? So after this, you will have a vector of street segment IDs for all of the intersections in the current map. Then how do we write the find street segments of intersection function then? It will just be one line, returning one vector in the outer vector, accessed by the intersection ID. And the complexity will be O1 with one direct memory access. Does this make sense? I'll take that as no questions. And after this, if you run the intersection test again, you'll see that the performance test has passed. And you might notice that we have a performance test for load map too. but you will have several seconds to load everything into your data structures. So it is safe to use O(n) time complexity to load your data structures. And if you don't do anything too crazy, you will be able to pass it. And that's the end of this tutorial. Let me know if you have any questions about this. So all of the functions in milestone 1 will be of a similar fashion.